Hello there. This is a cool clock that I saw on Hackaday. I'll link to the article, and the creator is Bastel Garage. I'll link that below too. But I like it to be cooler and, dare I say, a bit more functional. This is very much of an art piece. I love the way the LEDs wash on the wall, but it's hard to tell what time it is, and not just because the blue seems to be especially underpowered under the ring light I got here. Does that help? Maybe a bit. I like my light to be white, but anyways. Our makerspace doesn't have enough cool things on its walls, and I thought putting something useful up there would be pretty nice as well. However, it's a little small, it's a little hard to read, but still, I mean, just as a cool piece, it's cool. I'll get to the redesign in a bit. I just wanted to point out how easy this was to make. Here's the brain of it. Wemos D1 Mini. I've opted for one with a USB-C port just for the ease of powering and programming. So this right now, it's just plugged into the wall, powering it, but this is the same thing you use to program it. D1 Mini is built around this ESP8266EX Wi-Fi chip. It's a Wi-Fi module with an 80 megahertz ARM processor on board, as well as a dozen or so I/O pins. There's one analog pin somewhere. Let's see how close we can bring this and zoom in for you. Focus. Oh, that's very nice. The only other part we needed to add, this is what's called a level shifter. The Neopixels that are making this light up like to run on 5 volts, and the processor here runs on 3.3 volts. So this takes the 3.3 volt signal and bumps it up to 5 volts. The red line here is a 5 volt run, just straight from the USB, and the blue is the ground. So you're controlling these LEDs with 3 wires: signal, ground, power. Very beautifully simple. It can be programmed with the Arduino IDE. These things cost about $5 and they're crazy popular. So all of the software libraries for this project were written long ago, long before Bastel Garage got to them. The actual code is less than 100 lines, and half of those are blank lines or comments. The other half are German, since this gentleman is from Germany. But still, very easy to read, and, there's not enough complicated code in the clock to cause problems. Because this is a Wi-Fi module, it's actually going out to the internet, grabbing NTP time signal, so the only thing you actually need to program, if you want to just run his code straight up, is to set your time zone. It uses a separate library, so when you plug it in, it identifies itself as a Neopixel clock. If you have more than one of these, you probably want to change the name. But then you can log into it, set the Wi-Fi username and password wherever you're at, and that's that. The final bit of this project, this clock, the LEDs used. These are Neopixels, arranged in a ring of 60 pixels. Actually 2 rings, one for the hours on the inside and minutes on the outside, pointing in opposite directions. To control each Neopixel is a tiny addressable processor with a red, green, and blue LED attached. So to control all 120 of these, you need just the one data line. Each Neopixel passes the data on to the next, and the next, and the next, and the next. And these are actually wired in a loop. I have this first ring connected to the second ring. Not in a loop, just in a straight line. There's nothing connected to the other end. If you want to, you could use the other end to inject more power, but the data signal is rejuvenated by each LED, so you never need to worry about injecting more data. What I used, or what Bastel Garage used to light these, is Adafruit's Neopixel library. They have a huge tutorial that I'm going to link below, and I highly recommend Adafruit's tutorials for anyone getting into any electronics project. Even writing tutorials, you should look at how well they do. They don't just tell you what to do, but also what not to do and what kinds of things you can get away with. Anyways, the clock is a lovely piece of art as it is, but I'd like it to be a bit more readable and a bit more kinetic. I'm not sure it really counts as kinetic if it doesn't have any moving parts, but if we blink the LEDs a bit, I think we can get away with it. What's also nice about this as a kinetic sculpture is that it's going to be silent. There's no moving parts. I do get the occasional complaint that Space Cat of the Infinite Spin is kind of distracting. And yes, Space Cat is still spinning at the new Nova Labs location. It's been going for close to 2 years at this point. Anyways, I'm going to unplug this guy. So with this, you can see data line coming in, goes to the first Neopixel ring, the minute ring, comes out of the minute ring, it's connected straight up to the hour ring, and then I could connect up more if I want. This is the one I'm actually working on. I built a strict prototype just to make sure it was looking okay. Okay, so my first whack at making this a more usable clock was to add some lines and numbers to the clock face, and I also went into the code and added a second hand. So we have 60 LEDs for the hour, 60 for the minute, but they're RGB LEDs. So, shall we plug it in? I also excavated some pits in the clock face, so you could tell which light was on. Started off at the wrong time, figured out the right time. So for the second LEDs, I'm lighting up the hour and the minute and having it pop around. But that gets the idea of, you can see what's on. Again, this camera the blue is a bit more visible in person, but maybe I'll actually swap blue for the inside and have green on the outside, because the greens are just brighter than the blues in general. The amusing part is, there's nothing to index the faceplate on the old version. I actually had to add little notches on mine to make sure you line the 12 up with the top. Remember, on this guy, it's just a ring. If this was on crooked, you'd have no idea. Did glue it in place so that it wouldn't, fall apart. It all just press fit together. This is actually the first one I started working on. So we have the breadboard here, and I know the wires look a little crazier, but it's basically your standard breadboard wiring, where when I'm not sure how to mount a module, I'm using these two power buses for the 5 volt, one for the 3.3 volt. And because how this is set up, you have to cross it back and forth. But the same level shifter. Trying to throw the diagram out. Ooh, that looks cool. See the blue? I think the blue is it's too far off the surface. Yeah, I'll modify it some more. But just working out the system by the pins, you can see we only have one actual data line. And then there's just the power lines. Really love the look of this terracotta PET G. I think I'm going to rebuild the circuit into that and start it over again. However, this doesn't make it any bigger, and unfortunately, you can't buy these Neopixel rings any bigger. What can you do about that? I'll sneak over to the big printer for a look. So the next upgrade is to see how big I can make this clock. This is not a terrible size, but unfortunately, this is the largest Neopixel ring that you can get. Now, you can get Neopixels in strips. And here I've taken the strip, it has an adhesive backing, and I've folded it back on itself. So for the clock, we're first hitting the minute ring on the outside, going clockwise, then the hour ring on the inside, going counterclockwise. Do the same thing here. Set that aside. With the strip having the LEDs pointing outwards, this would be purely side firing. So as long as I got the sizing right. Okay. So with the LEDs in, you can see the features. We have dog bone shaped connector here. So this is just using a little extra 3D modeling, a little longer printing, to get better separation between the LEDs. Yeah. These are both printed on the XL. They easily fit on their build volume. This is, again, extra channels for the LEDs, little pips to drop the tops of these guys, and the notches to make it easier for a human to read as a clock, and the numbers, of course. I didn't like the numbers and lines, and I wanted to keep it 2 colors so people with the dual extruder XL can print it. But yeah, I'm pretty happy with the way it looks, but I think I'm going to do some more tweaks on the faceplate. I'll probably install it at the labs and ask people for their opinions and see if anything shakes out. Anyways, thanks for watching. Happy printing.